please, to set your calculator up exactly the way I tell you, because that way we'll all be looking at exactly the same picture, okay? So let's first of all go to mode. Everybody's going to mode. Okay? Everybody, Mason, you with me? You have to go to mode. And one of the options in mode is POL. I want you to highlight POL. Guess what POL stands for? Polar. You are now putting your calculator into polar mode, which means, kids, that the graphs now are going to be circular. They're going to be like the graph paper that you had, okay? Now, while you're here, would you double check and make sure you're in degrees? Everybody in degrees. Well, they're in different lines. So you're both. Okay, so we're in degrees and we're in polar. All right, now go to window. And notice now it says, now it's talking about thetas. Yes, because theta is one of the polar variables. R and theta are your variables. So here we go. Theta min, 0. Just put in what I tell you to put in. Theta min, 0. Theta max, 360. We're going to go one time around. We're in degrees, remember, so we're going to go one time around. Theta step, 3. We'll talk about what difference that makes in a minute, because that's kind of a new one for us. X min. Let me look at my equation real quick. X min, let's go with 4. Negative 4, excuse me, negative 4. So for X min, negative 4. For X max, positive 4. X scale, 1. Y min, negative 4. Y max, positive 4. And Y scale, 1. Joey, what are you doing? All right, everybody got it? Now, go to y equals. We're going to put in an equation now. And when you press y equals, it doesn't say y equals anymore, does it? What does it say? R equals. Because look at the equation we're going to type in. We're going to type in the equation R equals 2 cosine 3 theta. Okay? So type that in. Now, Mrs. Ford, where's the theta button? The theta button is your variable button. So it's right under mode. It's the button you used to press when you wanted an X. Now when you press it, you're going to get a theta. So you're typing in 2 cosine 3 theta. Do not type 0. That is not a 0. You type theta, the theta button, which is on your variable button right under the mode button. Press it and a theta will come up. Okay? Now press graph. Oh boy. You get, actually, Paul, it's called a rose. This is called a 3-leaved rose. Now, again, you are graphing a circular thing on a rectangular screen, so it's not quite as well shaped as it could be. So press the zoom button right here on the top, the zoom button, and then go down to number 5, which is zoom square. And when you hit zoom square, it will square up the screen for you so that everything is the same size. All the leaves are the same size. You see what I mean? When you originally graphed it, it looked like one was maybe a little bit longer. Well, now you can see they're all the same size. Okay, everybody got a 3-leaved rose? All right. Questions are, how many leaves, how long? Well, you've already answered how many. How many leaves? There are 3. How long 2. You should be able to tell that from your graph. We set the scale at 1, so you could just count hash marks. They're 2 units long. So you graphed this equation. It's a 3-leaved rose, has 3 leaves, and they're 2 units long. So this equation produced this. All right, so let's look at the next equation, which is 4 cosine 2 theta. All right, so same questions. How many, how long? All right, so graph it.
Whoa.
How many? How many leaves did you get this time? For this equation, you did not get 3 leaves. Not for this equation. This one gave you how many? 4. There are 4 leaves to this equation. Can you tell how long they are? You should be able to tell how long they are. They should go right to the end of your screen, the way we set it up. So they are 4 long. So this equation was a 4-leaved rose. It has 4 leaves, and they happen to all be 4 units long. All right, next. 3 cosine 4 theta. Same questions. How many, how long? So you're graphing 3 cosine 4 theta. How many do we have? 8 leaves. Can you tell how long they are? 3. 8 leaves, 3 units long. One more. What about 5 sine 5 theta? Now we may have a problem with this one, I don't know. It went off the screen. So if it went off the screen, that means we need to make our screen bigger. So maybe X and Y, max and min should be 6, -6 and 6. Try that. Sometimes we have to make adjustments to see the picture. Well, as long as you can answer the question, that's fine. We want to know how many and how long. How many are there? 5. Somebody say 7? No, wait. This does not have 7. And how long are they? 5. All right. Now we have done 4 graphs. They've all been, somebody called them flowers. Technically they're called roses. They've all been roses. All these pictures. Now I want you to make some observations about the equation and the result. The equation had, all these different equations have 2 numbers in them. Number here and number here. What impact, look at what happened in all these problems. What impact does this first number seem to have? How long they are? Doesn't that number always, every single time, turn out to be how long they are? Every time? So if I had some random equation and I did not give you a calculator, so you could not graph this, you would all be able to tell me, maybe not how many just yet, but you'd be able to tell me how long they are, right? They're 10 units long. That number out in front functions like the amplitude number. It tells you how big the thing is. All right, now what does that other number control? Well, that other number controls how many leaves there are, how many petals there are. So let's see what we observed. When that number was a 3, we had 3. When that number was a 2, we had 4. When it was a 4, we had 8. And when it was a 5, we had 5. So it's either the same or doubled. Would you agree with that? Based on our examples? When is it the same and when is it doubled? Is it random or is there a pattern? Mason?
If it's odd, it's the same number, but if it's even, it's doubled.
Exactly. So this number right here tells me how many leaves there are. If that number is odd, that's how many there are. So if that's a 3, there are 3. If that's a 5, there are 5. If it's a 7, there are 7. If that number, though, is even, then there are twice that many. So if it's a 4, there are 8. If it's a 2, there are 4. So this one, this random equation, how many leaves is this going to have? That's an even number, so it's going to have 8. When you look at roses, equations of roses, you can always look at the equation and tell how many leaves there are and how long they are. So I'll give you one more. This is a rose. I don't expect you to know that, although you probably do after graphing all these. But if I tell you it's a rose, I expect you to be able to tell me how many leaves and how long they are. Okay, so how many leaves do we have? 7. How long are they? 6. So here's our rule again. Take a note of this so that you remember it, because we're not going to go back through all this again. This number right here tells you how long they are. Whatever it is, that's it. That number's a 6, they're 6 long. That number's a 5, they're 5 long. This number controls how many there are, but it depends if that number's odd or even. If it's an odd number, you have that number. If it's an even number, you would have double that number. Okay? We're going to look at 4 curves, 4 kinds of curves. One of them is the rose. I've just spent all this time talking about it. You graphed 4 of them. You got it, right? The rose. Done. All right. Now, I want you to leave everything set the way it is on your calculator, and we're going to look at the next curve, which is 6a. Now, this equation looks different. Would you agree with me? It looks different? Why? What's different about it? It's got a subtraction in it. If they have an addition or a subtraction, they're not a rose. Roses are just one term, one multiplication term like this. If you put an add or subtract in it, we're going to get a different shape. We'll type it in. Let's see what shape you get. It will not be a rose. Tony, you need to stay focused, buddy.
Wait, is this what you got? Yeah, look at the chunky one.
Circle with a small circle. Oh, what does it make? It's a knife. Make it look like a little heart.
Yeah, I like what I hear.
Kinda.
You get something that looks like that?
Some of it.
This figure, this kind of curve here, all those were called roses. These are called lima signs. And you will remember this. You will remember that this is a lima sign because it has the shape of a lima bean. a lima B. So a lima sign has the shape of a lima B. Okay? Now, it's not on your paper, but I want you to do something for me. Would you take this exact equation, only would you change this to a sign? And tell me what happens to your picture. If you leave everything the same, leave the numbers the same, minus all that, but make that a sign. What happens to the picture? It just rotates. It opens or, is situated a different direction. When you change from sine to cosine, the shape never changes. The only thing that changes is the way it's oriented, the way it's sitting. Okay? Now, I'm a little bit curious because the question there is, it says sketch. Okay, we did that. And then it says, is it a cardioid? Well, here's what I'd like you to do. Sketch problem C. Sketch problem C. I skipped B. I'm going straight to C. Sketch C. Tell me what is different about C. Well, the size will change, but there's something else that's different about it. It doesn't have this loop. So basically, kids, what we have is a shape that looks like this. Now, I don't know about you, but that looks like a heart to me. That is what we call a cardioid. So what is a cardioid? It is a special lima sign that doesn't have that interior loop. And what makes it a cardioid in the equation, you can tell when you look at the equation. What makes it a cardioid is that these two numbers are the same. When those two numbers match, and they can be added or subtracted, that's irrelevant. If they are the same number, you have a cardioid. So look at problem B. Will problem B be a cardioid? No, because you have a 2 and a 3. But will problem D be a cardioid? Yes, because we have a 3 and a 3. They can be plus or minus, doesn't matter. If the numbers match, you have a cardioid. So I could give you a quiz question. No calculator. I could say R equals 4 minus 4 cosine theta. Cardioid or not? And you would say yes, because these two numbers are the same. Okay? So how do we tell a cardioid? Well, the problem's going to have a plus or a minus in it. And these two numbers are either going to match or they aren't. Alex, you need to try and stay awake, honey. If you're not feeling well, you can go to the office. Okay? I think this is cool stuff. I can't imagine going to sleep during this. All right, we're going to do one more curve today. One more curve. There are 4 altogether. So what have we done so far? We've done the rows. And what do we need to be able to identify about the rows? How many leaves, how long they are. Then we looked at the lima sign, and the only thing we need to know about the lima sign is it a cardioid or not? We need to be able to graph it on our calculator, that's easy. But then we need to be able to tell, is it a cardioid or not? All right, the next one we're going to do looks different yet. What is different about, I'm now on problem 7, what is different about this equation? There's something different about that equation. It's an R squared. All right, now listen. When you go to graph this on your calculator and you press the Y equals button, does it say R squared? No. You have to square root it. But wait a minute. When you square root it, you need to do this square root, and you need to do this square root. So you are going to type in 2 equations. Now, some of your calculators, as soon as you hit the square root button, they're going to put a parenthesis here. That is awesome. Then you're going to type 9 sine, and they're going to put another parenthesis there. That's awesome. Just close them both, and you're done. That's good. Same thing with the bottom equation. Put a negative out in front of the bottom one. So square root 9 sine 2 theta. Negative. Make sure you're using the negative button and not your minus button. That would not work. Now this is a little unfortunate, and I am not, I'm just not a calculator pro, so I'm not quite sure how to address it. But what you actually get is this shape, okay? They look like they're not connected there in the middle, but they are. They circle all the way around and come together at the origin, okay? That's the shape you should get. Now, I get that it looks like it's open here on your calculator. You just gotta trust me, it's not, kids, it's closed. There's something going on, I don't quite understand it. Sometimes this happens. Okay? Now, listen. What curve is this? Well, what does it look like to you? What are some ways you would describe this? Okay, you could describe it as an infinity symbol, and sometimes it is sideways. Sometimes it's up and down. This one happens to be diagonal. Does it look like anything else to you? Okay, I don't know. I'll have to look. I don't know. Shock that. What's the deal here? We got to talk about this. We got to get this in. This looks like a figure 8 to me. A figure 8. And the reason I want you to think about it as a figure 8 is because its name is lemniscate. That's called a lemniscate. But if you mispronounce it, you could say lemniscate figure 8. Lemniscate. That's how it's spelled. Lemniscate figure 8. It's actually called a lemniscate, but lemniscate figure 8. That's what happens when you put a square into your equation. You get a figure 8, a lemniscate. So if you were going to graph the other one, oh, by the way, can you tell how long the leaves are on your figure 8? They're 3. How do I know they're 3? What's the square root of 9?
3.
3. And what does that number in front tell you? How long they are. So those leaves are 3 units long. The square root of 9. Letter B would be another lemniscate, but those leaves would be 4 units long. And it might be situated a different way. Okay, so next time, which is that tomorrow? Yay. Well, yeah, but it's only going to take part of the period because it's only quest.
How long is the class?